All right, for this screencast, we are going to create the equivalent to OD45. So we're going to essentially integrate an ordinary differential equation. And in MATLAB, that's using the function OD45. In Python, we're going to use the Scipy toolbox and ODEInt. Okay, so let's say we have x double dot plus 5 times x dot plus 3 times x equals 3 times cosine of t. All right, there is our differential equation. So we put that in first order form and we say z equals x and x dot. And so z dot is x and x dot and x double dot, like that. And x double dot is obviously 3 times cosine of t minus 3 times x minus 5 times x dot. And I'm going to call this ODEInt example dot pi. Okay, so it turns out we can actually turn this into a function. So create a function. So I'm going to say def. So instead of function like MATLAB, it's def, and I'm going to call it derivatives, and the inputs are t and z, and x is the first element, and O, by the way, arrays start with 0 in Python, not 1 like MATLAB. Get used to it. X dot is z of 1, like this. X double dot is 3 times np dot cosine t, and so I need to import the numpy toolbox. T minus 3 times x minus 5 times x dot, and so I'm going to return. I'll say z dot. I'll say z dot is np dot as array of x dot and x double dot, and that should be it. And then I'm going to return z dot. So this means z dot is my output. Okay, so everything below here now, this is the main script. And oh crap, I forgot about something. So in Python, everything needs to be tabbed correctly. So first of all, there needs to be a colon there to signify that this is the start of a definition, and then everything needs to be tabbed. Otherwise, it doesn't know how to differentiate between the function and the main script. So make sure your code looks neat. Okay, so for the main script now, what we're going to do is we're going to integrate for 10 seconds, say, and I'm going to say t out is np.linspace of, well, let's not do linspace. Let's see, how do I want to do this? Let me pause record. Okay, yeah, let's just do linspace. So I'm going to say t out is np.linspace. I'm going to say 0 to 10, and let's just do 100. Well, let's do 1,000 data points for now. Okay, so now you need to integrate. So what you're going to want to do is you're going to want to import import scipy.integrate as I. And so just like np, I'm going to have I now. And so now I need to integrate, so I'm going to go over to one of my older examples and copy this line of code. And that is going to be zout I.ODEInt derivatives. That's the name of the subroutine. And then the initial condition, so this is z initial. And so z initial is np.asArray. What are my initial conditions? 0, 0? Sure. And then t out is my vector. And so now I should just be able to do, import matplotlib.pyplot as plt. And I'm not going to do the PDF thing. I'm just going to do plt.plot t out, comma, z out, and plt.show. Is it running? Z initial is not defined. Did I spell it wrong? I did. Oh, okay. I think I have this backwards. This is z comma t. Sometimes it's backwards there. All right, look. It looks like I've got. I forgot close all. Where is that? Main script. Here's the main script. plt dot close all. And what do I have? Sweet. Okay, so which is which? There's two lines on here. So x out is z out of all comma the first row column, and then x dot out is z out of all comma the second column. So let's just plot x, and what do we get? There we go. So there is x. How do I know it's right? Well, there's two ways. I could increase the time step just to verify that, this is doing what it needs to be doing. So you could solve this analytically and plot the analytic solution on top of this. You could convert this to the Laplace domain and use the control system toolbox and plot that. But really, as long as you have this set up correctly, this should be right. I really don't have no reason to believe that this is wrong. So I'm just going to say it's right. You can add in all of the grids and labels and stuff like that if you want, and you can save it or use that PDF toolbox to do that. But that is how you integrate ordinary differential equations in Python using Scipy. All right, if you have any questions, post in the comments below. Hope you enjoyed this. Good luck.